Hello everyone, welcome to In 5 Minutes. In this video we are going to see the type 2b of multiple integration, that is integration over a given area using polar coordinates. So till now we saw the Cartesian coordinates. In Cartesian coordinates we have the equation in terms of x and y when we have the limits also in terms of x and y. But in polar coordinates we will be given our equation in terms of x and y, but we will convert that equation into polar coordinates in terms of r and theta. Why we should convert the x and y coordinates into polar coordinate? Because the equation in this coordinate is very difficult to solve, or it is very complex equation. Whenever we have a complex equation, we can convert that complex equation in terms of polar coordinates, and in polar coordinates that equation will become simple. Okay, so what is the representation or what is the conversion between Cartesian coordinates to polar coordinates? So for that, let's consider our coordinate axis. So these are our y-axis and x-axis. Let's say we have one random point in this plane here, which is P. So what is the distance of this point from the origin? The distance of this point from the origin is this line. So this distance is known as r. Okay. So what will be this distance? This distance is nothing but our x-axis. Okay, let's say this point is P of x comma y. So this distance is x-axis, this distance is r. What is this distance? Let's say this point is y, so this distance is y, and this line is at angle theta. So now if you see here, we have the x coordinate of this point, which is this distance. We have y coordinate of this point, but we don't know what is r and theta. So we can convert this x and y coordinates in terms of r and theta. So we get x equal to r cos theta. So this x is nothing but we rotate this r here. So here we have x equal to r cos theta. So in terms of r and theta, this line, that is this distance, is r cos theta, then this distance is r sin theta. So we substitute x equal to r cos theta and y equal to r sin theta. Then we get x square plus y square equal to r square. Okay, so this is the basic conversion of Cartesian coordinate into polar coordinates. Why we need this and why we required this will be more clear when we see the problem in this type. So let's take one example. So this is our question: solve this course integration where r is the loop of the curve. This is one curve. We all should know what is the equation of basic curves. So this curve is nothing but lemniscate. Lemniscate is nothing but it is a two loop curve, something infinity sign. Okay, so we are going to draw this curve here neatly. So this is a lemniscate curve. The equation x square plus y square the whole square equal to x square minus y square is lemniscate. So we will draw this curve. Okay, so this is our lemniscate. So if you see here, this is the equation of curve, and in type 2a problem we used to consider a strip parallel to y-axis, and we write the lower end of the strip and we write the upper end of the strip in terms of y. But if you see in this equation, we cannot write our equation in terms of y. First we have to expand this bracket, so it will be a plus b the whole square. Then we have to separate all the y terms so that we get y equal to some function and y equal to some function. So this is a very complex equation, and we cannot write the equation of lemniscate in terms of y equal to some function of x. So that's why we need to convert this problem into a polar coordinates. So remember, whenever we have a complex curves like lemniscate, we have to convert our Cartesian coordinate into polar coordinate. So the substitution will remain the same. We put x equal to r cos theta, we put y equal to r sin theta, then x square plus y square will be r square, and dx and dy will be r dr d theta. So this is the basic conversion of Cartesian coordinate into polar coordinates. So now we will substitute all the terms. So we get our integration will become I equal to integration over region r, dx into dy is nothing but r dr d theta. So we have r dr d theta upon 1 plus x square plus y square. We are substituting it as r square the whole square. So this is our new integration in polar coordinates.